Hi. All right, so here we go. Oh, we're frozen up here. Okay, good. All right, now we're presenting in class. My fat head out in the corner. All right, gonna proceed on a Friday. I don't think this is too bad. It's kind of more the same of yesterday, and there is like one new thing though, and I'm gonna approach maybe different than the other teachers. One of the questions a little bit differently, the way I used to do things. Okay, one of the sheets that you picked up is the homework sheet, and I made it real small because the powers that be said we should do these and then go into that magic book. Now to put that on the calendar, I just realized I didn't update the calendar for our quote book assignments, and I still haven't legally gotten you those codes. I'll probably have to wait till Wednesday and ask one more time, how do I do this, and then maybe deal with that Wednesday with you guys, and then be legal there. But here's all the fundamental theorem of algebra is, and we kind of actually already. Where am I doing draw? There we go. I don't know why that was changed. Kind of exercise this a little bit, but not really. The degree of a polynomial is exactly how many. Now let's all say the word together. Complex. Complex zeros there are. What's complex? I made a mistake on this when I first started teaching. I thought complex was another word for imaginary, and it is not. Complex is the whole subset of numbers that takes care of both real and imaginary numbers. So complex means them all. Be worried about multiplicities though as well. Multiplicities count in that degree of how many zeros there are. So that's what you're guaranteed. Yesterday we did the rational roots theorem. That's for rational zeros, not for irrational or imaginary zeros. So that's what we're delving into today, even though I did do it yesterday, where one of them had, I think we ended up with imaginary zeros yesterday when yeah, it was x squared plus x plus 1. And then we did the opposite of b plus or minus the square, blah, 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 blah. Okay, so we can still do the rational roots theorem. But watch how some of these questions are very specifically worded. And then if we do get a success, then we can continue the factoring process, or we might have to use the quadratic formula. That's what number 5 says. And then list all the zeros. So let's go ahead and start this first one. Let's pretend we're in 2008. I got no graphing calculator. This is on the non-graphing calculator part of the test. So I set up my P over Q list. Now, a lot of times we are nice. We had a really bad example yesterday that the first one that worked was 5 halves. Remember that one? All right, we had to go through a real long thing there. But anyway, 1 and 3, and then 1 and 2. Those are the factors of the constant, P. I forgot what colors I used. I think it might have been green and yellow. It doesn't matter. And then the factors of the leading coefficient, and then list them. I guess we could write the plus minuses there. And then 1 half, 3 halves. You don't want to write that plus minus so many times. You could use that parentheses thing. Okay, let's hope one works. And because I'm doing a trial and error way, I'll show you the Samulus. It's not my way. I've seen many books do this, where I can do my trial and error way, and I don't have to keep rewriting 2, -1, 2, -3. Make sure your polynomials in descending order. I think I've done a bad job of mixing them up on you so that we can make the point that if you don't put those in descending order, you're going to be wrong on synthetic division. And then, of course, we'll try 1. Bring down the 2. 1 times 2 is 2. 2 plus -1 is 1. 1 times 1 is 1. 1 plus 2 is 3. Hey-oh, look at that. And usually we are nice. Maybe not 1 -1, but maybe the next one 3 -3. And any fool that tries 2 and -2, they're wasting their own time because they're not doing the rational zeros theorem. And then this is what we mean. We got a depressed polynomial, and we're going to work with it. How you MA this one, this is a way of factoring, like to do a 4-step thing. And I don't want to cover that yet until I run into a really tough factoring question. But do you remember this? The M number is actually 6. How many people remember that and never done that before in factoring? You should raise your hand because I showed you this last year. What? Okay, one more time. How many people remember that the M number is 6 on that longer way of factoring, and then the A number is 1? Nobody? Everyone's just looking at me like they want to kill me, and that's fine. But does anyone remember this at all? Anyone? No? Okay. Well, what I was going to try to say is that is your M number 6. Does anything multiply to 6 and add to 1 if someone's not? Does anything multiply to 6 and add to 1? Multiply to 6 and add to positive 1? No. Okay, I actually want to get a really hard factoring question and show you what I'm talking about here because I know 1, 2. Who else did I have last year? Who are my other last years? 3. Okay, I showed you that long 4-step factoring where M is 6 and then A. No, nothing. Okay, because you know why though? That's good. I don't think they use it because they really try to unfoil and check all combinations. Sorry, the opposite of b plus or minus square root of b squared minus 4. There you go. AC all over 2a. So I guess today's notes, I was not supposed to do this yesterday. I was supposed to say, you know what, that's imaginary. They said only real zeros, don't do anything. Kind of have to delve into the quadratic formula to see that they're imaginary. But anyway, isn't that right? Before AC summons Mr. Samuel, listen to me. What's wrong? Did I do something wrong? Huh? Where? All over to A. Got it. All right, gotcha. All right. Okay, 4 times 2 is 8, 24. Oh, that's nice. 1 minus 24 is negative 23. Why is that nice? It's prime, which means I have to do nothing. Negative 1 plus or minus I root 23. The only thing I have to do is take out an I, right? All over 4. So find all the zeros of the function. Notice you have an x cubed. This is what the fundamental theorem of algebra is. And I have 3 zeros. 1, 2, 3 with the plus minus. Notice those come in plus minus pairs. Oh, do I dare? Oh, I don't think I want to. Let's go to the graphing calculator. Let's pretend this is on the graphing calculator one. Okay, and I'm going to slide this over here so as the calculator opens, I can type it on there easily. It really is time consuming and a waste of time now that we have technology to go through a trial and error. And I have to double depress this. So hopefully you're faster than me trying to find my stuff here and move my head and then slide this across. I don't know why that didn't stay on the smaller side. Okay, I do like you knowing that we're in class. I'm going to leave that open there. All right, y equals, okay, then you can catch up with me. Wrong, I'm going to clear that. I don't like seeing all that old stuff. So 3x carrots, delicious, 4 arrow right plus 5x carrots. Did I tell you that carrots are a good snack for dogs? Okay, fine, jeez, got it. Carrots are good snacks for dogs. They didn't hear this. They didn't. All right. Plus, my dog goes crazy for him now. 45x. I'm glad someone said, good for your dog. All right. Okay, now, I think I'm Zoom standard 6, but I'll just make sure. Oh, no. Okay, that one is not nice. So I'm wondering, like, if I zoom this out a little bit, because I know on my P over Q list, 18 might be a number. Oh, that'd be really rough. So I don't see any double zeros. This is kind of rough. I'm wondering what happens here. I'm wondering with you. I'm going to go to 20 to negative 20. I don't see any others. So that's going to be a fractional one. All right, so then I can go to my P over Q list and find the fractional zeros. Maybe that's an idea. But doesn't that look like negative 2 is one of them, right? Yes. And then I'm going to look for a fraction in my P over Q list that's less than 1. I'm actually just doing this on the fly. I actually expected 2 nice whole numbers. All right, so we'll see what happens. Oh, and I have an idea what that is. You know, one of my zeros is going to be 1/3, right? Right, one of my P over Q lists. And I'm looking at that with 3 being a leading coefficient. I bet you 3x minus 1 is one of my factors. 3x minus 1, that gives me 1/3 is a 0. So I'm going to make an educated guess that it's -2 and also 1/3. Let's see if I'm right. And if I'm not, I'm going to be really sad. So now that I see -2, I'm going to do this the old way. 5, 25. Sorry, I'm slowing down here. 3, 5, 25, 45, 18, negative. Another thing we're doing a disservice. Not only do we not have these in order for you already, be careful. There's no missing terms. Account for missing terms. So 3, I'm going to be really sad if 1/3 doesn't work. I'm going to be really sad if this doesn't work. 2, 27. -2 times 27 is -54. Hey-oh. This is -9. And then -2 times -9 is 18. So there's the calculator. We don't have time on a test to have you searching for zeros. We'd be really jerky teachers, I think, if we did that. And then especially in this one, we have to double the press. And then remember, this is now an x cubed. Wait a minute, maybe we don't. Okay, do you notice this polynomial here? Look at this polynomial. 3x squared cubed minus x squared plus 27x minus 9. Isn't that factorable? How would that be factorable? By what? Grouping. That's factoring by grouping. But you know what? I went through that whole thing in my head, and I think I saw 1/3 as a 0. And then we'll show you how you write this like in factored form after. So I'm going to stick with that. Although that's factorable by grouping, and you can pull that out and factor it and get your, and then that's where you're going to see a 3x plus 1, minus 1, minus 1, minus 1. Anyway, bring down to 3. 1/3 of that is 1. You're gone. 1/3 of 0 is 0, but that's 27. And lo and behold, what I saw was correct. Okay, so I used my P over Q list as an idea with that fractional 0 that I saw. So it was something from yesterday. So a whole bunch of things could happen that you have to be aware of. All right, and then this is x squared equals, subtract 27, divide by 3, unfortunately, -9. Maybe not unfortunately. What are the other two zeros? What are the other two zeros, everyone? Anyone? Plus or what? These guys aren't saying anything. They're just looking at me again like they want to kill me. Plus, minus, take out a I. So plus or minus 3i. Now, some things that we ask you in the homework. I feel like the homework is a little lengthy. I almost feel like I want to cut it down for you. Would that be okay? You can't tell anyone though, because if anyone else finds out, then I'll get in trouble. All right, because every class has to do the same thing, or else the Gestapo, I can't even say the word, they'll arrest me and take me in the, wherever. Okay, so those are the zeros. Zeros, 1, 2, 3, 4. But what if you had to write this in factored form? Okay, so in factored form, -2 being a 0, that's easy. That's x plus 2. And they do ask you in this, like in the notes, get the zeros, but then also write it, I guess, in factor form. I have to look at those directions. I do, no, actually, I don't think I have the homework ready here. But look at our leading coefficient there is 3x to the 4th. So this is not x minus 1/3. This actually is 3x minus 1. Then that gets me my leading coefficient when I FOIL this out. And you got to account for that if you had to write this in factored form. So A, I got the zeros. B, now I can write it in factored form, basically factor the polynomial. And then what's weird, for the I numbers, we can make separate binomials for that. So it's x minus a 0. That's it. So here are the zeros. Here are the z's. Boom, boom, boom. All these. Here it is in factored form. And you're able to do that immediately. We'll see in the complicated directions, maybe in the homework, how you're supposed to write that. But I cannot overemphasize this. The reason this came about is because of that. You got to make sure you ensure the leading term. All right. So that's why I highlighted all three of those parts. All right. All right. Okay. What's the matter? Oh. All right. So zeros come in conjugates. Let's all sing together. The opposite of b. What's next? Plus or minus. And then underneath the square root, you could get an I number. But when a polynomial has real coefficients and it's a quadratic, and I use the quadratic formula and get I numbers, by golly, they come in conjugates. Can everyone say conjugates? Conjugates. So if a plus bi is a 0, then a minus bi has to be a 0. If the polynomial has real coefficients, in which that's what they always do. They always do. All right? So quadratic form, complex number is 2 minus I. What must the other one be? By golly, it must be 2 plus 5i, because the opposite be plus or minus the square root, blah, 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 blah. Now, I pulled out your homework for this next one, but I'm going to wait. I'm going to do this different. Don't tell anyone. Gestapo. All right? But I am going to do this the way we used to do this back in regular cat days. Okay, I'm going to ignore this sum and product thing. I'm going to do this example 3 the old way that I used to do it. Then we're going to use this idea and further, describe it, and then do this kind of question a different way. And then you can do whatever you want. I'm grading your tests. No one else is. If you decide to go this way, you'll be safe in my room. It's a safe place. Okay. No, some people don't feel that way, but especially when I punch walls and stuff. But some students bring it to me when they make the same mistakes over and over and over and over again. Look at how large I'm making this here. Look at how far apart they. Wrong! What did I do wrong? Anyone? It finally happened. It finally happened. I lost the spot. Okay, you may or may not like this. Okay, I couldn't. Anyone? Care less. Okay, I like to show you different ways. So 17, 14. Notice the space I'm writing. And I think this would be on probably the graphing calculator portion. But what should happen if 1 minus 2i is a 0? What should I get here? What should I get right here? What should I get? 0. So I should be able to synthetically divide with this I number and get a 0. And then I'm going to employ the complex conjugate theorem, because these all have real coefficients. So if 1 minus 2i is a 0, what else has to be? 1 plus 2i. This is how we always did this back in the day. So 4, first one's easy. 4 times 1 minus 2i is just a distribution, right? And then to add that to 0, this is 4 minus, well, this is the weirdest coefficient. And then what do you do next? You multiply. Oh, no. And then this is where you might have a graphing calculator for this. You could literally type this exactly as it is on your graphing calculator and get that answer. But I'm a good foiler, which makes me a what? Good factor. -2, negative. This is 16i squared, which is -16. I did the i's. I did the -2i and the -8i. I squared is -1. It also required that you remember that, which I do believe we covered in here. And then I'm going to do the O and the I and write that separately there. This is -8i, and this is another -8i. So that's -16i, correct? Right? Did anyone type this on their calculator?
No, I didn't.
And press enter? Can someone do that real quick and make sure I'm right? So this would be 4 minus 16, which is -12 minus 16i. Is that right? Okay, so you can do, if you're worried about your foiling and not knowing what I squared equals, which is a problem, you're supposed to know I squared equals -1. That's how I got this -16 here. This was positive 16i squared, which turns into -16. Oh my goodness. And then I add these. Isn't that 5 minus 16i? I'm really nervous here. And then you take this times this. For purposes of notes, 1 minus 2i. Go ahead and type that on your calculator. What's 1 minus 2i times 5 minus 16i? What do you end up getting? This is probably why you may not like this way, but the other way is just as lengthy and challenging. What do you end up getting? -27 minus 26i. Oops, sorry. Okay, so I'm being lazy there. And what is that? Is that negative 13 minus 26i? Is that right? Shoot. Okay, then let me see what we had there. 13, 20. Wait, yes, this is good. Okay, right? You agree with that? Now take the last two and multiply them. Take 1 minus 2i. I'm trying to stay out of the way of the question there. 1 minus 2i, and I guarantee you get negative 65. Is that true? Did you get negative 65? Isn't that wild? So this product right here ends up being negative 65, which is 0. Isn't that wild? Okay, so back in the day, we used to make the students, we probably wouldn't go as large as these numbers, like 5 and 16, 13 and 26. They definitely had to do this way. So proof, and then guess what? This is now an x cubed. Look at these coefficients. Oh, who cares? Watch how easy this is. What else is a 0? What else is a 0? 1 what? Plus 2i, and now, oh, you're like, oh my gosh, I have to synthetically divide again. By the way, this column's now dead because it's now an x cubed. Watch how easy this is. I bring down the 4. Look, 4 distributed, 4 plus 8i. Oh, look at that. That becomes 8 there. That's nice, right? I don't have to do any more calculator work. It was just that first round. That was awful. Next one is distribution. 8 plus 16i. Nice. This is 13. And then 13, oh my gosh, plus 26i. Are you kidding me? I got a 0 as a remainder, which proves this is a 0. So I sell, if you're an insomniac and you have trouble falling asleep, then I have this alarm clock, and that setting, you just press the button and it's me teaching. You know, and then it turns into an alarm clock, and then I wake you up. So I got this item if you ever want to, because anyone that sleeps in my class, you will instantaneously be awoken because it's not allowed. Oh, sleeping in my class, what a signal! Now, what do I have to do for this last part? Is it? Let me see. 13. Yeah, I don't see factoring going on this at all. No way. The opposite of b plus or minus the square root of b squared minus 4ac. I forgot I was taping. 4ac. So mean. Sleeping. All over 2a. Okay, right? Did I do that right? 4ac. Yeah. What's 4 times 4 times 13? What's 64 minus that product there? What's 64 minus this product there? What do we end up inside there? Huh? Negative what? Are you serious? That's nice. Negative 8 plus or minus. I'm having all these students help me with these numbers. This would not be no calculator. These numbers are too big. Okay, we're not going to make you do that. That's jerky. And then negative 8 plus or minus. Square root of 144 is 12i. And then everything's divisible by 4. So it's negative 2 plus or minus 3i all over 2. No, those 2's do not cancel. That's why you divide everything by 4. Or separate it into 2 separate fractions. You could also have this. Negative 8 over 8 is negative 1 plus or minus 12 over 8 is 3 over 2i. So this is the exact same thing, all right? But I'm making a point that the 12 gets knocked down with that 8 as well and reduced. This is the biggest mistake people make. They only take the 8s and cancel, all right? Those are identical. This just has common denominators with the numerator all together there. Okay, so this is an option, or did I skip this? You could think about this, but this requires memorization. This is a property, and I'm actually going to go to your homework and show you some questions. Are we only halfway through? Is that like the middle of the lunch change? Oh, great. How many things do I have to stamp? One?
Okay. Yeah, one.
Okay, so here's what's true about this, what I could have done on this last question, but I'm going to do the next one like this. And it's called the sum and product of roots theorem for quadratic equations. This is true for any quadratic. Really, I think it has to be x squared, I believe. I don't know if there could be a number in front. Yeah, a has to equal 1 for this to be true. Yeah, so just making sure that that condition was there. All right, a little worried that there was something wrong with our notes. Then this number right here, it's the sum of the roots, but it's the opposite of that sum. So if I have two zeros, that middle term is always the opposite of what the sum of the roots are. And then this last term is always the product of these roots. And it is true. And I'm going to exercise that here in a little bit. And I thought they had an example of this somewhere in the notes. That doesn't work anymore, squeezing that screen there. No, they don't. So here, go to your homework sheet. I pulled this here. Oh, that's where I'm thinking. It's in the homework sheet. So I wanted to reference this instead of it coming out of nowhere. Then on the homework sheet, they randomly throw these things in there and put an example in there. So I just wanted you to be aware of it. Okay, so let's say we have a quadratic whose solutions are 5 and 1. Well, then this is the quadratic, and I can prove it. Good foilers, say it. This factors to be x minus 5, x minus 1, right? Isn't that right? And then I get 5 and 1 as zeros. Well, look at the two zeros, 5 plus 1. 6 in the middle, but it's the opposite of that sum. And then look at the product of these two zeros. 5 times 1 is 5, and it is the last term in that polynomial. See? So the sum and product, this happens all the time, and we're going to prove it. Here's one of them. Well, here's 2 and negative 5. The sum of those is negative 3. The product of that is negative 10. So the polynomial that must be, or the quadratic that comes from these zeros, must be x squared minus negative 3x minus 10. So that's plus 3x minus 10. So it's minus the sum of the zeros for the middle term. So, of course, this becomes x squared plus 3x. I don't know why. X squared plus 3x minus 10. Then, of course, you know this factors to be x plus 5, x minus 2, and then we circle all the way back to this. Yes, those are the zeros of that polynomial. That's the tie-in. This makes it true. Everyone okay? This requires you memorize this, though. One little mistake, is it opposite of this or opposite of that? You're gone. All right? And that's why, boy, I tell my Math 2 regulars, you gotta get this stuff memorized and get it figured out. All right? Moving on. I don't get this. Well, you got to get it memorized. It's not I don't get it, it's memorize. That's a different thing that requires some effort, requires some stuff. Whatever. What's the sum of these two zeros? What's the sum of those two zeros? What's the sum of 2 root 3 and negative 2 root 3? This is not a hard question, fourth hour. Zero. That's all I got. Someone on their deathbed. Zero. Okay, and then what's 2 root 3 times 2 root 3? What's 2 times 2? Oh, gosh forbid I ask that question. 4. What's root 3 times root 3?
3.
What's 3 times 4?
12.
So 12. So guess what? It's x squared minus 0x. Do I have to write that? Plus 12. And then, of course, if I solve that, x squared plus 12. Wait a minute. Something's wrong here. Product, what did I do wrong? Oh, it's a negative product. What a maroon. I knew something was, isn't a positive times a negative and negative? I knew something was wrong because I was going to check my answer. All right, so it's x squared minus 12. So I got to erase that. My bad, dogs. And then you add 12 and root. And then, of course, square root of 12 is 4 times 3, 2 root 3 plus or minus. So again, you don't need to do this part. I'm just proving it. I'm tying it back to the idea that we're establishing here. All right, now I'll tell you where this is going in our next thing. And I really feel I needed to do this to get you to understand how I'm going to do the next part. What's the sum of these two zeros? What happens to the root 2's? What happens to negative 3 plus root 2 plus negative 3 minus root 2? What happens to the root 2's? They cancel. Thank you, somebody. And then what's negative 3 plus negative 3? Negative 6. And then what's the product of these two zeros? Well, you better be good foilers, anyone? But you should know when you multiply these two, and then I'll zoom in on this, that this becomes 9, this becomes minus 2, and what happens to these middle terms? They cancel. So it's just 9 minus 2. I just wanted to make sure that was correct. Which is what? 7. Okay, so weirdly, this is x squared. Yes, it sounds like it's factorable, but it is not. Minus negative 6x, and then plus 7. If the 7 and the 6 were switched, it'd be factorable. I'm like, wait a minute, that seems factorable. So this is x squared plus 6x plus 7. Not factorable. If I went through the quadratic formula, I would get those as the answers, okay? So it would work. I'm not going to bore you with that, okay? I want someone else to fall asleep. Oh, kids these days. So how can I use that information to do this question differently? You could very well do this. Do synthetic division of 1 minus root 2. Was that fun? With the calculator, was it okay though? I mean, it was doable. It's doable. You can type the numbers in there. So what you can do is actually, since I have to find the remaining zeros, well, here are the zeros. The zeros are 1 minus root 2, we know that, and 1 plus root 2. Oh, why? Because there's also the imaginary root theorem, or I'm sorry, the irrational roots theorem, which is the same as the imaginary roots theorem. They have to come in conjugates too, because same reason. The opposite of b, say it, plus or minus square roots. So when you get a polynomial with real coefficients, the root numbers must come in conjugates as well. Okay? So I know that. So boy, I wish I could reduce this down to an x squared and get the other two zeros. Well, you can. You can find the polynomial that has these two as zeros by the product sum idea. Okay, so the sum of the two zeros equals 2, right? The root 2's cancel. And then the product of the zeros is 1 times 1, which is 1, minus root 2 times root 2, which is 2, negative 1. Right? Did I do that too fast? Fine, I'll write it out. 1 minus root 2, 1 plus root 2. Good foiler, say it. Can't help myself. I did 1 times 1, and then I did negative root 2 times root 2. What happens to the middle term? What happens to the middle term? Cancels. That's why I don't care. So it's 1 minus 2, which is negative 1. And then create that polynomial. Okay, so what is that polynomial? It's x squared minus the sum plus the product. That's the polynomial that has 1 plus or minus root 2 is zeros. And then what am I going to do with that polynomial with x to the fourth? I'm going to divide. I'm going to divide out that x squared out of that x to the fourth. I'm going to be left with an x squared. Okay? So I couldn't, anyone? Care less which way you do it. You could very literally have done this other one the same way I showed you this. I don't think the other two teachers are even showing that method. I may be wrong. But again, I couldn't. Anyone? I kind of don't tell anyone. I don't want to get in trouble. I got to watch every step. I'm being watched. Anyone? Have you guys read 1984? Anyone? How many people have read 1984? Raise your hand. You're being watched. Big brother. All right? Minus 2x cubed. You're just a number. You're just a data point. X squared. I go into all these meetings with just data. How do we get these turn these kids into numbers? All right? I shouldn't be saying this, but all right. So, okay, so you get that? product and sum of zeros, and how I can make that polynomial a polynomial and then long divide. Everyone okay? All right, I don't know about this hour. No one says a word. What goes up on the top? What goes up on the top? X squared. Thank you. Someone does care about my misery up here being all by myself, no one listening. Minus 2x to the third. Oh, that's interesting. X squared times -1 is negative x squared. Okay, so distribute, and then distribute a minus sign. Yoink, yoink, yoink. You're gone. You're gone. That's nice. 2x squared. That means I get to skip to the end. We're going to have specifically. I better get a remainder of 0, though. Otherwise, this is. Oh, no, I don't need a. Oh, yeah, I do need a remainder of 0. Because this is supposed to be in this situation here. All right, now what do I have to do? I have to multiply by 2. So hopefully you heard what I was saying there. I kind of caught myself in a bad statement there. You definitely need to see a remainder of 0 because these are zeros of this. So this polynomial, having both of these zeros incorporated, should go evenly into that polynomial, right? That's what I was knocking around in my brain there. And lo and behold, sure enough, it does. Negative, distributed, you get nothing, nothing, and nothing. Okay? So that actually was not that bad. That may be a choice that you like. I don't know. But the remaining 2 zeros come from this depressed polynomial now. X squared plus 2 equals 0. X equals -2 square roots. So that means plus or minus I lost my minus in my head, root 2. And then weirdly, I don't know what they have in the directions. And now I probably should go to that and look at the direction. But I think, I wonder if they say over complex numbers, you want to write this in factored form. If that was the case, then it would not be that bad. It'd be, what do I have as a leading coefficient? Good. X minus 1 minus root 2. That's how you'd write it. And maybe put brackets instead of parentheses. This is how you write it in factored form. It's always x minus the 0. All right? Whatever the 0 is. You know this in simplistic forms. These are just more complicated. X minus 1 plus root 2. Then, of course, you can distribute the minus sign and write this a little bit cleaner. All right? It doesn't matter. And then this one's just parentheses because it's just x minus I root 2. And then x plus for minus a negative I root 2. Because I think in the homework it says, oh, okay, and then also write this in factored form. All right, that's what you got to do. If the 0 is 4, then it's x minus 4. If the 0 is I root 2, then it's x minus I root 2 for the factor. All right, it's the same idea. Okay, I could shut this puppy down.